Lightning protection is required for the 13,000 square foot Class 1 Division 1 expansion area. According to the National Fire Protection Association 70 National Electrical Code, the following areas require lightning protection. Firstly, areas classified as Class 1, Division 1 or Class 2, Division 1. Secondly, areas containing flammable or combustible liquids or gases in quantities above certain specified limits. And thirdly, areas containing hazardous classified locations. The original plant, which currently does not have lightning protection, may also require due to the following reasons. Firstly, the installation of lightning protection on the expansion area may create a potential difference in electrical potential between the original plant and the expansion, which could increase the risk of lightning strikes to the original plant. Secondly, the flammable and combustible materials in the original plant may present a hazard in the event of a lightning strike. Here are some recommendations. 1. Conduct a lightning risk assessment for both the original plant and the expansion area to determine the specific lightning protection measures required. 2. Consult with a qualified lightning protection installer to design and install an appropriate lightning protection system. 3. Consider extending the lightning protection system to the original plant to ensure the safety of the entire facility. Here are some additional considerations. The lightning protection system should be designed in accordance with National Fire Protection Association 780 standard for the installation of lightning protection systems. The lightning rods should be installed on the roof and grounded properly to the earth. The grounding system should be tested and maintained regularly to ensure its effectiveness. Lightning protection systems are designed to protect structures from damage due to lightning strikes. They work by providing a low impedance path for lightning current to flow to ground, thereby preventing the current from flowing through the structure and causing damage. A typical lightning protection system consists of air terminals, also known as lightning rods, conductors, and a grounding system. Air terminals are installed on the roof of the structure and are designed to intercept lightning strikes. Conductors are used to connect the air terminals to the grounding system. The grounding system is designed to dissipate the lightning current into the earth. The design of a lightning protection system should take into account the specific characteristics of the structure being protected, including its size, shape, construction materials, and location. The system should also be designed to meet the requirements of applicable codes and standards, such as National Fire Protection Association 780. Regular inspection and maintenance of lightning protection systems are essential to ensure their continued effectiveness. Inspection should be performed at least annually and after any significant weather events, such as lightning storms. Maintenance should include repairing any damaged components, tightening loose connections, and testing the grounding system. In Class 1, Division 1 locations, special considerations must be taken when installing lightning protection systems. Class 1 locations are those in which flammable gases or vapors are or may be present in the air in quantities sufficient to produce explosive or ignitable mixtures. Division 1 locations are those in which such flammable gases or vapors are present continuously, intermittently, or periodically under normal operating conditions. In these locations, all electrical equipment, including lightning protection systems, must be explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain any explosion that may occur within the equipment, preventing it from igniting the surrounding atmosphere. Intrinsically safe equipment is designed so that it cannot release enough energy to ignite a flammable atmosphere. In addition to using explosion-proof or intrinsically safe equipment, other precautions should be taken when installing lightning protection systems in Class 1, Division 1 locations. These precautions include grounding all metal components of the system to prevent static electricity buildup, using shielded conductors to prevent electromagnetic interference, and ensuring that all connections are tight and secure. A lightning risk assessment is a process of evaluating the likelihood and severity of lightning strikes to a particular structure or area. The assessment takes into account factors such as the location of the structure, its height, its construction materials, and the surrounding terrain. The results of the risk assessment can be used to determine the appropriate level of lightning protection for the structure. The first step in a lightning risk assessment is to gather information about the structure and its surroundings. This information may include the following: firstly, the location of the structure, including its latitude, longitude, and altitude; secondly, the height of the structure; thirdly, the construction materials of the structure; fourthly, the surrounding terrain, including the presence of trees, buildings, and other structures; and fifthly, the lightning strike frequency in the area. The next step is to use this information to calculate the risk of lightning strikes to the structure. There are several different methods that can be used to calculate this risk, including the rolling sphere method and the cone of protection method. The rolling sphere method is a graphical method that involves rolling a sphere of a certain radius over the structure. The radius of the sphere is determined by the lightning strike frequency in the area. Any point on the structure that is touched by the sphere is considered to be at risk of a lightning strike. The cone of protection method is an analytical method that involves calculating the angle of protection provided by a lightning rod. The angle of protection is determined by the height of the lightning rod and the distance from the lightning rod to the structure. Any point on the structure that is within the cone of protection is considered to be protected from lightning strikes. Once the risk of lightning strikes has been calculated, the next step is to determine the appropriate level of lightning protection for the structure. This decision should take into account the following factors: firstly, the risk of lightning strikes; secondly, the potential consequences of a lightning strike, such as fire, explosion, or damage to equipment; and thirdly, the cost of lightning protection. There are several different types of lightning protection systems available, including lightning rods, surge suppressors, and grounding systems. Lightning rods are designed to intercept lightning strikes and safely conduct the current to ground. Surge suppressors are designed to protect electrical equipment from voltage surges caused by lightning strikes. Grounding systems are designed to provide a low impedance path for lightning current to flow to ground. The installation of lightning protection on the expansion area may create a potential difference in electrical potential between the original plant and the expansion. This potential difference can increase the risk of lightning strikes to the original plant. To mitigate this risk, it is important to bond the grounding systems of the original plant and the expansion area together. Bonding involves connecting the grounding systems together with a heavy gauge conductor. This conductor should be sized according to the requirements of National Electrical Code 250.66. In addition to bonding the grounding systems, it is also important to ensure that the electrical systems of the original plant and the expansion area are properly coordinated. Coordination involves ensuring that the overcurrent protective devices in the two systems are properly sized and coordinated to prevent nuisance tripping. The flammable and combustible materials in the original plant may present a hazard in the event of a lightning strike. Lightning strikes can generate intense heat and sparks, which can ignite flammable materials. To mitigate this risk, it is important to store flammable materials in a safe location away from potential lightning strike points. It is also important to ensure that the plant has adequate fire protection measures in place, such as fire extinguishers and sprinkler systems. Grounding is a critical aspect of lightning protection systems. A properly designed and installed grounding system provides a low impedance path for lightning current to flow to ground, thereby minimizing the risk of damage to the structure and its contents. The grounding system should be designed to meet the requirements of National Electrical Code 250. The grounding electrode system should consist of one or more of the following: firstly, a metal underground water pipe; secondly, a metal frame of the building or structure; thirdly, a concrete encased electrode; fourthly, a ground ring; and fifthly, rod and pipe electrodes. The size of the grounding electrode conductor should be determined according to National Electrical Code 250.66. The grounding electrode conductor should be connected to the grounding electrode system at a point that is accessible for inspection and testing. The resistance of the grounding system should be measured periodically to ensure that it is within acceptable limits. A low resistance grounding system is essential for effective lightning protection. Regular testing and maintenance of lightning protection systems are essential to ensure their continued effectiveness. Inspections should be performed at least annually, and after any significant weather events, such as lightning storms. Maintenance should include repairing any damaged components, tightening loose connections, and testing the grounding system. The lightning protection system should be designed in accordance with National Fire Protection Association 780. This standard provides detailed requirements for the design, installation, and maintenance of lightning protection systems. The lightning rod should be installed on the roof and grounded properly to the earth. The lightning rod should be located so as to provide adequate protection for the entire structure. The grounding conductors should be routed as directly as possible to the grounding electrode system. The grounding system should be tested and maintained regularly to ensure its effectiveness. The resistance of the grounding system should be measured periodically to ensure that it is within acceptable limits. Any necessary repairs or replacements should be made promptly. National Fire Protection Association 780 provides comprehensive guidelines for the installation of lightning protection systems. It covers various aspects, including risk assessment, system design, component selection, installation practices, and maintenance procedures. Adhering to National Fire Protection Association 780 ensures that the lightning protection system is properly installed and provides adequate protection against lightning strikes. The selection of appropriate lightning protection components is crucial for the effectiveness of the system. Air terminals or lightning rods should be made of corrosion-resistant materials such as copper or aluminum. Conductors should be sized according to National Electrical Code requirements and should be securely fastened to the structure. Grounding electrodes should be chosen based on soil conditions and should provide a low resistance path to ground. Surge protection devices should be installed to protect sensitive electrical equipment from voltage surges caused by lightning strikes. Proper installation practices are essential for the performance of the lightning protection system. Air terminals should be securely mounted and properly spaced to provide adequate coverage. Conductors should be routed in a straight and direct manner and should be securely fastened to the structure. Grounding electrodes should be installed in accordance with National Electrical Code requirements. Surge protection devices should be installed close to the equipment they are protecting. Regular maintenance is necessary to ensure the continued effectiveness of the lightning protection system. Inspections should be conducted periodically to identify any damaged or deteriorated components. Grounding connections should be checked for corrosion and tightness. The resistance of the grounding system should be measured to verify its effectiveness. Any necessary repairs or replacements should be made promptly. Consulting with a qualified lightning protection installer is highly recommended to ensure that the system is properly designed, installed, and maintained. A qualified installer has the knowledge and experience to assess the specific needs of the facility and to design a system that provides adequate protection. The installer can also provide guidance on maintenance procedures and can perform regular inspections and testing. The National Electrical Code provides requirements for grounding and bonding of electrical systems. Grounding is the connection of electrical equipment to the earth to provide a low impedance path for fault current to flow. Bonding is the connection of different metal parts of a structure together to create an electrically continuous path. Grounding and bonding are essential for safety and for the proper operation of electrical equipment. The National Electrical Code 250 covers grounding and bonding requirements. It specifies the types of grounding electrodes that are permitted, the size of the grounding conductors, and the methods for connecting the grounding conductors to the grounding electrodes. The National Electrical Code also specifies the requirements for bonding different metal parts of a structure together. These requirements are designed to minimize the risk of electric shock and to provide a low impedance path for fault current to flow. Explosion-proof equipment is designed to contain any explosion that may occur within the equipment, preventing it from igniting the surrounding atmosphere. This type of equipment is used in hazardous locations where flammable gases, vapors, or dust may be present. Explosion-proof equipment is designed to meet specific standards, such as Underwriters Laboratories 1203. These standards specify the construction requirements for explosion-proof equipment and the testing procedures that must be followed to ensure that the equipment is safe. Explosion-proof equipment is typically more expensive than standard electrical equipment. However, it is essential for safety in hazardous locations. When selecting explosion-proof equipment, It is important to choose equipment that is appropriate for the specific hazard that is present. It is also important to ensure that the equipment is properly installed and maintained. The National Fire Protection Association is a non-profit organization that develops and publishes codes and standards related to fire safety. The National Fire Protection Association codes and standards are widely used in the United States and around the world. The National Fire Protection Association 70 National Electrical Code is the most widely used electrical code in the United States. It provides requirements for the safe installation of electrical wiring and equipment. The National Fire Protection Association 780 standard for the installation of lightning protection systems provides requirements for the design, installation, and maintenance of lightning protection systems. The National Fire Protection Association codes and standards are constantly being updated to reflect the latest technology and best practices. It is important to stay up to date on the latest versions of the National Fire Protection Association codes and standards to ensure that your facility is safe. Flammable and combustible liquids are liquids that can easily ignite and burn. Flammable liquids have a flash point below 100 degrees Fahrenheit, while combustible liquids have a flash point at or above 100 degrees Fahrenheit. Flammable and combustible liquids are used in a wide variety of industries, including manufacturing, transportation, and agriculture. These liquids can pose a significant fire hazard if they are not handled properly. It is important to store flammable and combustible liquids in approved containers and to keep them away from sources of ignition. It is also important to have adequate fire protection measures in place, such as fire extinguishers and sprinkler systems. The NEC defines hazardous locations based on the type of hazard present and the likelihood of the hazard occurring. Class 1 locations involve flammable gases or vapors, Class 2 locations involve combustible dusts, and Class 3 locations involve ignitable fibers or flines. Divisions further categorize the likelihood of the hazard being present. Division 1 indicates that the hazard is present continuously, intermittently, or periodically under normal operating conditions, while Division 2 indicates that the hazard is present only under abnormal conditions. These classifications dictate the type of equipment permitted in these areas. Only equipment specifically designed and tested for the hazard is allowed. This includes explosion-proof enclosures, intrinsically safe circuits, and purged and pressurized systems.